Hi, good morning, everyone. My name is Neil Sanders. I'm a principal technical account manager at AWS, and I'm joined by a guest speaker from Koch Agriculture and Energy Solutions, Dave Croning. He's the Edge Technology leader there. And today we'll be covering a AWS service called Monitron. It helps in predictive maintenance of your industrial assets. And here's the agenda. So we're going to talk about the typical um, preventative, predictive, and um, uh, typical maintenance patterns that we see at customers and how they scale these maintenance strategies. And we're going to talk about Monitron and how it can help with your predictive maintenance practices at scale. And then we're going to hear from Dave how they moved from being an early adopter of Monitron to a large scale user of Monitron, and what are some of the lessons they've learned along the way. And then at the end, we'll take a couple of questions. So let's get started. Now, a typical manufacturing plant or a fulfillment center has thousands of equipments, right? So these equipments have to be up and running 24/7. Now, the plant operators or the reliability engineers, that's their day-to-day function to make sure that the plant can meet its production targets. However, there are these unplanned downtimes that impact the productivity, and obviously that impacts the bottom line at the end. Now, they have maintenance strategies around the typically there are three main stages of maintenance strategies. The first one is the reactive maintenance strategy, which is do nothing till something breaks, right? So that's not all recommended, obviously, but customers do follow these strategies sometimes due to various reasons. It could be that these equipments are not in the critical path, or these equipments are very difficult to reach, and maybe they're in hazardous environments, or there are several reasons for which customers do take these strategies sometimes. However, that's not recommended. The next option is going through the preventative maintenance, which is have a schedule, could be a weekly, monthly schedule, have someone go to the asset and check the status of the assets. Now, again, that's not recommended, but customers do follow those strategies sometimes. And these preventative strategies could be non-invasive, where someone goes and checks the temperature or vibration of those assets, because typically these two uh, indicators means there's a friction within the assets and there's something wrong and that needs to be reviewed. Or it could be invasive, where the operator or the person who's measuring these have to put in probes within these assets and check whether the electricity is flowing through those devices or not, if there's any anomalies there. Both have their own challenges, and the biggest challenge is it's not real time, right? You have to schedule. It's like your car maintenance. You take your car at a regular schedule at a 5,000 miles per every 5,000 miles you take it for maintenance, but it's not real time, right? So, and wherever there is these um, maintenance schedules, you have to send a human to go there and take those measurements. And wherever there is human intervention, there's concerns for safety as well, particularly in hazardous environments. During those environments, during these tests, there's service disruptions, which lead to cost and sometimes significant loss in the revenue as well. The third strategy is predictive maintenance, which is what we recommend. And what it means is take your actions before certain outage happens, right? So that's almost real time and detects anomalies. You need to review the historical data and then take actions before something breaks. Now, that strategy, although is recommended, is not easy. there are several challenges in implementing such a strategy at scale. The first one is you have to have sensors. Install these sensors across your factory floor. Um, the sensors have to take measurements, and then this data has to be processed at scale. It has to be stored somewhere and processed, and then typically this process has to you have to run some analytics or machine learning models on those to identify what the issues are and then detect the failures. And then obviously these have to be sent to an operator managing who are managing these. So creating an ecosystem of solutions that will build something like this is pretty overwhelming. It takes some time and expertise. So based on customer feedback and working with customers like Dave, we have come up with a solution called Amazon Monitron, which is a managed end-to-end predictive maintenance solutions for industries. What Monitron does is it has these wireless sensors that you can put it in your environment, and it collects data real time 24/7, and these are sent to um, our cloud, where they are then processed using ISO standard models, using 20816 standards, and then it measures vibration and temperature, and then these sensor data is processed real time. You could see historical data, compare it, and identify anomalies. And then it also has sensors managed by us with wireless gateways and Ethernet gateways that we manage and place it within your factory environment, within a secure and within your intranet as well. So let's go a little deeper into how it works. But before that, so there's one more slide where I wanted to give some examples of where these um, equipments have been placed today. We have equipments all across different manufacturing assets like pumps, fans, compressors, motors, gearboxes, bearings across all these industries like bottling, paper plant, textile, heavy machineries, automotives, and consumer packaged goods. So on to a little bit how it works. So on the left, you have your operation sites. So typically these operations sites have machineries, and you assign or attach a sensor to these assets. These are wireless sensors. So it's pretty much use an adhesive and attach it to the sensor. You could have multiple sensors on an asset depending on how large these assets are. And then you commission these assets or sensors through a mobile app. And once this is commissioned, it starts collecting data from these assets. They send these data over to a gateway, could be an Ethernet or wireless gateway through Bluetooth. And once this data is on the gateway, we send it to our Monitron service through your wireless network securely. On the cloud, we process the data. We, typically 2 to 3 weeks after the sensors are installed, it starts detecting, patterns. So it takes 2 to 3 weeks to learn how your environment works, and then it starts sending alerts after that. Now, it will identify patterns and anomalies. It uses, like I mentioned, the ISO standard models, and then those data are sent to your operators, handheld devices, or even mobile desktops as well. And this is how a desktop and mobile app looks like. On the left, these are all the different assets. It can be configured by your projects and sites, assets, as well as positions within assets. If you have multiple sensors within a given asset, and it detects, for in this particular case, there's some issues with the left bearing. You could see the historical data of the vibration charts, and then double click on it. You'd see how did it perform for in a day, and then you see there's an anomaly, and then operator can acknowledge those, respond to whether it was a valid alert or not, or it's a false alarm or not, and then it can process alerts on it. And I'll come to that in a bit. So that's how the end-to-end process looks like. But to conclude, It's a continuous process. It's not a reactive or preventative process. It learns as it goes. So, you're automatically detect these the assets performance on real time. You measure the sensors temperature or the assets temperature and vibrations, and then analyze the data at scale in the cloud and take some actions. It will alert you if there is any issues, and then um, you can detect anomalies. And these machine learning models improve over time. So as the operators respond to those reactions or the alerts, you can acknowledge, you can provide some feedback. Using this feedback, the model learns on its own. So over a period of time, the models learn your environment, and it's customized for your environment. So it's a continuous process, and as time goes on, you're customizing the models for your environment, and it gets much better over time. As we worked with our customers, like Koch Ag and Energy, um, we had requests from customers that they wanted to use it at scale, other in environments such as hazardous environments, right? So particularly for oil and gas or chemical industries where they have hazardous environments, they wanted to make sure that these sensors can be used in these environments. So we certified these assets for class 1 zone 2. um, uh, we got this class 1 zone 2 certification for hazardous environments, and for UK's explosive atmosphere certification, we have that as well for both UK and EU, the ATEX and UK EX certifications. Another topic I wanted to cover is as these sensor data are sent to AWS, these customers can take advantage of the large ecosystem of AWS services that we have to offer. So in our fulfillment centers, Amazon.com fulfillment centers, here's a use case where what we have done is we have these sensors in all these assets, and the data comes into Amazon Monitron, obviously the end-to-end asset monitoring. However, we send this data over through Kinesis to a IoT data stream where the data is processed, and we're sending these alerts to a Lambda function, and this Lambda sends it to an asset management system. It's a third-party asset management system that manages these, takes actions based on the activities that happen or alarms that were generated. And we also send it to our collaboration tool, Amazon Chime, where that starts a chat with the operator and some of the engineers on the field. So I just want to give you an example of a use case where the benefits of bringing the data over to the AWS ecosystem, because it can help you build custom solutions based on your environment. So there's a little bit of detail on how the architecture looks. Might not be legible so much, but on the left, you can see the Monitron sensor data to Kinesis data stream using V2 schema, and then using Firehose, we send it to S3 buckets, which triggers a Lambda function. And then we store the data for historical purposes as well, but it also generates a IoT event, which then maintains the state or measures the state of the asset, and then starts the application asset management interactions. And once it's done, it updates the status, and all of this is stored in DynamoDB for historical purposes as well. And then at the end, the states are sent to Chime for collaborations. So with that, I'd like to hand it over to Dave to talk about how they moved from 4 or 5 sensors all the way to hundreds of sensors and how the journey looked like. Dave, over to you.
Yeah, thanks, Neil. And good morning, good afternoon, good evening. I'm going to give a little background of our implementation here at Koch Ag and Energy Solutions on how we scaled Monitron across our fleet. So just a high level to give you an overview of our company. We have a lot of physical assets where we manufacture nitrogen-based fertilizer products, and as well as distribute. We also manufacture methanol, and then we buy and sell natural gas, as well as make nitrogen-based micronutrients that help feed a lot of the plants and help support the global food source. So a little background: a lot of our assets are manufacturing outside, to give you an idea of what that might be like. So, all right, let's dive into the actual deployment here. So we started on this journey back in 2020. We focused on the opportunity at that point was think big, start small, scale fast. And since then, we've shifted a little bit on our thought process, and we've been focusing on collaborating with the reliability and rotating engineers and those capabilities on where we should deploy Monitron sensors. That's narrowed down to our class 2, 3, 4 critical equipment, leaving the big, large compressors and assets to other technologies. So we have scaled out Monitron to a number of assets, and I'll go over that later. But we also seek to provide the context from those sensors back out to our operating capability so that they can then diagnose and detect what is going on out in the field. So our architecture with this solution is similar to what Neil had gone through. We physically attached a Monitron sensor with epoxy to our assets in the field. The data flows through our gateways, which we leverage the power over Ethernet gateways in most of our scenarios. That goes through our internal internet out to the AWS cloud. So from there, the Monitron app is leveraged internally with some of our analysts as well as our operations folks. But we also pull the data through a Kinesis stream to our local data historian, where then we build our own internal AI ML models along with the Amazon models to then share insights and feedback back to the operators. So that's kind of a high level of how we leverage of the data streams. So approach to deployment. This one's been interesting on our journey, and we wanted to share how we've looked at this differently. A lot of times when we take this solution out to the sites, we leverage instrumentation engineers and technicians, and they are working on current solutions in the field, and the wireless sensors seem to take a back seat or lower priority to those critical instruments. So our IT OT team definitely came in aligned to the vision and helped accelerate the deployment. So they had the knowledge around deploying the gateways as well as where the Ethernet ports were at and where our local wireless was. So really the knowledge to go deploy the sensors was simple as far as physically attaching, commissioning those sensors. So longer term, the ownership will transition over to the local site as we see pump replacements, sensors going out, those sort of things. That'll be done all at the local site. So quick visual on how we leverage the data. You can see on the left here is the Monitron app. The notifications on the phone are very helpful. They pop up, tell you what's going on, whether it's an alarm from an ISO limit exceedance or a machine learning model, whether it's vibration or temperature. So from there, we can do further diagnosis, looking at the data set, leveraged through our M&D team, which does monitoring and diagnostics, or the plant operations gets that notification and takes action. And then, as I mentioned before, we have our AI and ML models that we build, where we leverage other data sets like local weather when our assets are sitting outside, or other pressures and temperatures that potentially have an impact on those vibrations and temperatures from those physical assets out there. So our monitoring and diagnostic team evaluates that data, sends a notification via Teams to our plant operations so that we can take action. So high level overview of our business process using these sensors. So I want to share 3 wins here that we could talk through. This one was an interesting one on a cooling water pump. We saw a step change that was abnormal. The app notified us of that, reached out to the site to understand what was going on. They switched over to a backup standby pump. And we went out there and looked, and the site came back and sent us this picture, notified us that the shim pack had failed. So the shim pack is in between the coupler, and continue to operate like this can cause some misalignment and a potential downtime if we lose that coupler while that pump is in service. So good detection on the ML model here from the Monitron app, and avoided a potential catastrophic failure of that pump. This one was on a cooling tower fan in our Oklahoma facility. The Monitron app again had a couple different step changes, and this fan is critical to keeping our cooling water cool during the summer months, especially when it was 100 degrees out there. So we noticed a step change, had operations go out, take a look. They didn't really hear anything different, but what they were able to do was look at slowing the fan down. So the next day, we saw another step change take place, and the operations team started planning for a replacement as they could hear some audible changes based off the previous day. So we're able to get a motor on site and a gearbox, put the new sensors on, and planned out an outage to take this down so that we can do it safely as well as unimpacted to our production facility. And then the last one is an interesting use case as well. This is a blower that we have out in our aeration basin. Had some erratic behavior that we've noticed from the vibrations, and you can see in that trend they made some major step change versus what they did before. Went out, found out there's nothing wrong with the oil level, and so decided to just swap to our auxiliary blower. After further inspection, they found that inlet filter that's on the top of that blower there was plugged up, and then they just validated the belt alignment. So a way to look at condition-based maintenance in a different way on not always something failing, but also maybe something plugging up or a filter that needs to be replaced. So from 2020, we deployed those initial 5 sensors with the gateway just to get some traction out in the field. Then we started looking at limited scale, had conflicting priorities, like I had said about the instrumentation resources being consumed. Approached it differently with the IT resources and the OT resources. And so today we're at over 650 sensors deployed. And so we're capturing hundreds of anomalies that we wouldn't have seen with the prior method of capturing data once a month. And so we're going to continue to scale out the Monitron solution and eliminate a lot of our vibration rounds that we do manually, almost all of them. And then our approach to that has been mainly dependent upon the Class 1 Div 2 sensor that allows us to deploy the sensor in a hazardous area, like Neil had said, in chemical manufacturing. So a little bit on the Class 1 Div 2 sensor, that was one of the partnerships that we had with the AWS Monitron team, working together on identifying some of our gaps that we've had and what prevented us from scaling out the solution. So this certification that they went after took a little bit of time, but definitely helped us close the gap on what we needed to scale this solution. So with that, thank you for your time, and can open it up to any questions.
Thanks, Dave.
Thanks so much, Dave and Neil. Really great to see solutions like this for proactive maintenance. Open it up to the audience here. Feel free to use the raise hand feature or drop a question in the Q&A box.
If not, I have a question for you, Dave. Dave, could you share a little bit on what are some of the challenges you faced as you're moving from, let's say, 5 sensors in a POC mode to all the way up to 500 sensors, something that some lessons learned that others could also benefit from?
Yeah, I think first of all, we have several different facilities. Kind of the approach of getting started first. So we did implement at one facility the 5 sensors. So I think one of the biggest challenges was just moving forward. The cost to entry with the solution is low. So recommendation going forward would be to just buy the sensors, get them deployed, show the value that you see right off the bat. And then I think from there, then it'll just be a dependent, or it'll be a resourcing discussion on the value of people's time to go out and to scale out the solution. So, part of that is just purchase a small subset and deploy.
Got it. And then the other question I have is, as you were deploying this at scale, how has been your interaction with the AWS team, maybe particularly the solution architecture team or the enterprise support? Talk us a little bit on that as well.
Yeah, it's been a great partnership for us. Starting early in our journey back in 2020, when I just saw this out on the Amazon.com site and looked to scale it. So it's been a good partnership. We meet monthly with the Monitron team to provide feedback and give them any input that we have on the application, and then hopefully help to guide the product in a way that meets all the customers' needs that we're seeing. And continue to create value from the sensor as well as the analytics that come along with it.
Awesome. All right, that's all I had. Lauren, any questions from the audience?
Any other questions, folks?
If not, thank you everyone for joining us today.